just a little reminder. So we talked about measure of center, mean versus median, which one's better, when do we call something skewed, what direction do we say it's skewed. So if you looked at data, the first thing you'd want to go calculate are the means and the medians. Then to describe the data a little further, you would want to calculate that 5-number summary, like how it splits into the quartiles. And we talked about putting those quartiles in a box and whisker plot earlier. And then we talked about how we could even mark them on a histogram when we were looking here. Okay? Then the third thing that we wanted to mention was measure of spread. When you talk about data, you want to talk about how spread out the data is, because that tells people, like, is it really conclusive? All the data is in this one area, so you can say, like, at this happens. Or is it super spread out, and you have to take more things into consideration? So we talked about 2 measures of spread. One we already talked about before, IQR, okay? Interquartile range, that box part of the box and whisker plot between Q1 and Q3, okay? How long that is or how big that is. And then yesterday we talked about standard deviation and how if somebody's more standard deviations away from the mean, then it's kind of more spectacular, either on the low side or on the high side, right? But they're just like an extreme the further they get away from the mean, and we use standard deviation groups to measure that, okay? Then we talked about when to use which one. So we said if you have outliers, the mean and standard deviation get affected by that, and they're a little bit harder to use because we talked about like the Michael Jordan salary thing, right, and how he would totally skew the data. But if you use the median and the interquartile range, they are not as affected by outliers, okay, because they're a little bit more about counting towards the middle instead of adding them all up and dividing by something, okay, so they don't get skewed as much. So when you're collecting data, you're going to report all of them, and then you're going to decide which of these to use, depending on if your data has some extremes or some outliers or things like that. Okay? All right, so then we talked about how to calculate standard deviation. So we said it's this giant radical, and it had this weird notation, but we basically said all that means is that once you find the mean, the average, you take each piece of data, you subtract the average, you square it. You do that with the next piece of data, the next piece of data, the next piece of data, the next piece of data. You add those all together, and then you divide by 1 less than how many are in your sample size, okay? The 1 less thing in mathematics is to, like, give us a bigger cushion. It's not going to give us as good of a calculation, but we don't want as good of a calculation because depending on how many pieces of data we have, we might not be as accurate as we think we're trying to be, okay? So then we looked at a problem to try and compare. So this is where we left off yesterday. We already did the mean calculation, but to remind you of the problem we were looking at. So we were looking at this data, and this data was some outdoor paints that were tested and to see how many months they lasted, okay? So here's the data for brand A. You get all these numbers. Here's the data for brand B. You get all these numbers, and we calculated the average, and what did we get? What did we get as the average? 35 for both of them, okay? They both had very different data, but we got an average of 35. And so then we kind of proved our point that just looking at an average is not good enough to draw conclusions, because when you look at this visually, here's what it looks like, the information for brand A and the information for brand B. So if you really wanted to get just about 35 months out of your paint, which brand did we say that we would choose? B. There's more of them at 35. They're kind of all gathered right around 35. Okay. The average for this is a little more telling of what would happen. Okay. What's going on with brand A? It's all over the place. So even though it's equally spread and 35 is the middle, whether I find the mean or the median, is it important that I look at some sort of graphic display of the data? Yeah, because this really means, like, I feel like I'm playing a probability game, right? I don't know, pick your can. You're going to get somewhere between 10 and 60 hours. You don't really know because it's spread out equally all over the place. Okay? So even though there the average was 35, I don't feel like the average really tells me anything about the can of paint I'm going to get because it's so scattered, right? But here, I feel like the average for brand B does tell me about how long I'm going to get out of my paint because the data is really gathered around that 35, has a higher peak right here at 35. Okay? So then we want to see if the numbers could kind of back up that calculation for us. So what we did is we went and calculated the standard deviation. So this is kind of exactly where we left off. We had done the standard deviation calculation for brand A. What did it come out to be? 18.7? Okay, so our standard deviation for brand A was 18.7, and we want to compare that with our standard deviation for brand B. A little reminder about how we're doing the calculation again. We're basically taking a square root at the end of a giant calculation. For brand B, again, the average or the mean was 35. So each piece of data, we're going to find its difference from 35, and then we're going to square that. We're going to add all those things together. So because there's 6 pieces of data, I have to have 6 of these. I know that's going to bother you guys. Wait till you have like 20 pieces of data. It's okay. When we finish this today, we're going to see how to do it on the calculator so that you guys don't have to spend as much time doing it, okay? All right, each of these, I'm going to see the difference from 35 because 35 was the average. The numbers that I'm trying to compare to 35 are all the numbers that are in the data set. So 35, 45, 30, 35, 40, and the last number up there is 25. Okay. I'm going to take all those differences and square them, add them all together. Then I'm going to divide it by my number of data pieces minus 1. So instead of 6, I'm going to divide by 5. Okay. So we're going to go ahead. We're going to figure out what this is. And we're going to have the standard deviation from brand B. And the reason we're doing this like this is to help give us a better idea of what standard deviation is and what it means for a data set. I mean, I can tell you what it is, but until you kind of compare 2 data sets, you don't get like why it would be any different. So we're going to go ahead and add these up. 7.07. The standard deviation? Okay. Thank you, Jordan. We'll just round it to the 10th so it's equivalent. All right, so what do you notice about the standard deviation of brand A compared to the standard deviation of brand B? Okay, so brand A is a lot higher than brand B. Now remember what standard deviation meant to us. We kind of said if there was something that was distributed generally normal, okay, where the mean and the median are kind of in the middle, which both of these had, you have your average. And the more standard deviations that someone is away from the average, notice they're in a smaller portion of the population, they're considered more extreme. So if I said, oh, my height is 2 standard deviations above the average height of female Americans, you'd be like, oh, okay, so you're a little bit over here, right? That's not how we talk about it. We use descriptors like, oh, I'm tall for a girl, or stuff like this, right? But this is what it really means. And how tall am I? The standard deviation would give someone a better quantity of that than us just using descriptive words like, I'm pretty tall, I'm kind of tall, I'm very tall, okay? Those mean different things to different people, but standard deviation is more standardized so people could measure it. So I realize in everyday conversation you're not going to use it, but in data it would be important. So what this means here, with a standard deviation of 18.7, it means in order for you to be more than 1 standard deviation above the mean. So if I want brand A paint, okay, that lasts more than 35 hours, being beyond 1 standard deviation, I won't reach that until it lasts more than, let's see, 35 plus 18.7, 40, 53.7 hours is like just 1 standard deviation away. So when you go back and look at the data, like the picture, all the way to here, like 53.7, is still only 1 standard deviation away. Is 1 standard deviation away that amazing? No. Okay? So it takes a lot to get 1 standard deviation away, which means the data is really, really, really spread out if they're making a standard deviation that large. So the visual tells me and the standard deviation calculation tells me they had the same average, but look, this data is super spread out around that average, whereas look at this standard deviation. It's much smaller, and that means more of the data is closer to the average. So if it had its curve here, there would be its average, and its standard deviations would be closer together. So if I want to buy a paint that's more dependable, and I get an idea that it's going to last actually what the can says, I'm definitely going to buy something from here because a higher percentage of the data all falls in here. It's not as, there's not as many extremes. Over here, it's all over the place. It's super spread out. Okay? So standard deviation, when you get this number, the larger number is telling us the data is really spread out, which in this case is not what we want. Okay, if we're trying to make a decision that's like, oh, it's going to be like it said. I don't know if it's going to be like it said. It's all over the place. This one's a lot more likely to be close to what it said because its standard deviation or its spread is a lot smaller. Okay? So you guys understand how you can look at data. Let's say you were comparing, I don't know, female GPAs and male GPAs on campus. You could take them, you could calculate the mean, you could calculate the standard deviation. Maybe we have the same average GPA on campus for males and females, but then maybe one is really spread out and one isn't. That would be important in kind of saying like, well, they have the same average, but these ones are all grouped around that average, so those are going to kind of give me better results than these ones that are all spread out around the average. Does that make sense? Okay. So is everybody okay with standard deviation and that it's measuring how spread out your data is? So you can see in the pictures that we saw and the numbers here that makes sense. All right, so how to use your calculator. This is probably going to be a super important part to you because you probably don't want to have to go through and do all of these calculations by hand. So there are some calculators in the box back there. Here's one more, Ryan. There are some over here. You need to insert your ID to take my nice new rechargeable ones. I have one more up here. If anybody wants to use this one. So like the screen says up here, you're going to probably want to take notes on how to enter your data this way and how to do your calculations. So a couple of warnings. We've entered data in the calculator and we've done calculations, but for what kind of data? Scatter plot type of data, which is bivariate data. It relates two things together. Like we typed stuff in L1 and we typed stuff in L2, but the first thing in L1 went with the first thing in L2. They were two connected pieces of data like an XY list. Today we're going to use L1 and L2 also, but let's say this was my statistics project that I was comparing brand A paint to brand B paint. So I'm still going to have two lists, but are they connected together? No. One list is totally for brand A, and I need certain calculations to be done on that data. And one list is totally for brand B, and I need certain calculations to be done on that data. Okay? So first thing, to enter your data is going to seem similar. Go to Stat and go to Edit. If there's anything currently in your list, clear them out. So remember, that's not the delete button. It's the clear button on top of the name of the list, and press Enter, and it'll be cleared out. If you click delete, just use L2 and L3 or whatever. If you click delete, it like literally deletes the list. Like L1 won't be there. So on top of the name, press clear and press Enter.
Where did they go? They just went away?
Well, I can reload the memory of the calculator and it'll come back. But
You sounded so worried. Well, where did they go?
all right. So what I'm going to do, Matt, if you can't do this right there without talking, stop.
There's so many in there.
But it's distracting to me and other people, you know. Okay. All right, brand A. So I'm just going to put all the data for brand A in list 1. So the data was 10, 60, 50. You need to press clear on top of the name of the list and press Enter. 30, 40, 20. Okay, and make sure that you have 6 pieces of data. I know mine's good because I'm in this next blank spot that says it would be data piece number 7. Now I'm going to go in L2 and I'm going to put the 6 pieces of data that I have for brand B. Okay, so 35, 45, 30, 35, 40, and 25. Yes, Serena? No, it's not going to matter for this. All right, so that's how we enter our data. So if you're taking a note about entering data, same as before. Stat, calculate, put the stuff in the list. The difference between the lists here now is that these are not connected lists. One could be longer than another. Maybe I got more data about one type of person than I did about another, whatever the case may be. They're not correlated together. They're two separate lists for two separate ideas. Okay? All right, now to do some calculations. Just like before, we're going to go to Stat, and we're going to go to Calculate. So before, what we did is we ran a linear regression because we had a scatter plot, and we were trying to see what kind of line would best fit our scatter plot and how well it described our data. We're not trying to see that anymore. Remember all the slides that we just went through? The things we want are the mean and the median of the data, the 5-number summary of each of the data pieces, right, which is like the quartiles and all that kind of stuff, and the standard deviation, right? Those are the two things we want to compare. So if I'm trying to compare brand A to brand B, I want all the things that we just calculated. But I want the calculator to do it for me, so that when I have like 100 pieces of data, I don't have to do it myself, right? So those statistics are all one variable statistics. The reasons that they're one variable statistics is you want all those statistics about brand A, that is one number, okay, for each test in brand A, and then you want them all separately about brand B, okay? So you're going to go ahead and click one variable stats, and then you're going to tell it which list you want it to use. So if I want the information right now for brand A, I'm going to put list 1 after this, so it says list 1. Those of you that have the newer calculators, do they look the same? Okay, good. So those of you with the newer calculators for list, put whatever list your brand A stuff is in. The frequency of the list, you don't care, so you can leave that blank, and then you can press calculate. So for list 3, it would be right there. So you would just push second list 3. Okay. And then you can go down to calculate. All right? So if it's like mine, you type it in like this. If it's like yours, you just care which list, but the whole frequency thing you guys don't need to be worried about. You're going to press enter. So the X bar is what? Do you guys remember that notation from the standard deviation formula? The sample mean. Good. Okay. Nice job, Taylor. All right. So the mean of our data for paint A is 35. That shouldn't be surprising to us. We calculated that. See this capital S right here? SX. See right here where my mouse is pointing? Where did we get 18.7 calculation? Standard deviation for brand A. So there it is. The S is standard deviation. What does N stand for? When it says N equals 6, what is that telling me? There were 6 pieces of data. Now, keep scrolling down. That's not all. Look, the minimum is 10. The first quartile is 20. The median is 35. The third quartile is 50. And the maximum is 60. There's all the numbers I need to create my box and whisker plot, or if I created a histogram, those are the 5-number summaries. So this gave me my mean, my standard deviation, and my 5-number summary that included my median. Everything that we've talked about that measures the center or the spread of our data is all right here. Okay? So you could write all that down. Then you can either make your histogram or your box and whisker plot or both to compare your data. Okay? Then I want to go and I want to do the same thing for list 2, because if I'm comparing 2 data sets, I want to see what the mean and median of one are and how spread out it is. So data A, its measure of center was pretty clear because both the mean and the median were 35, right? So if I was reporting on this data, I would say how it's not skewed. It's pretty symmetrical. But the histogram would kind of show all those paints spread out. Like, yeah, it's symmetrical because there's one in every spot along the x-axis. And then the standard deviation of 18.7 would show me, like, look how spread out it is, as well as the length of the box and whisker plot, like the interquartile range and the range. Okay? So then to compare that, I'd want to make the same graphs I made for A for brand B. So either another box and whisker plot or another histogram to compare how they lay out. Okay? And so I'm going to do the same calculation I just did, but this time with my other list so I can see the stuff for brand B. So I'm going to go stat. I'm going to go to calculate, and again, one variable statistics. And this time I'm going to tell my calculator that it needs to use list 2, because that's where my brand B statistics are. Taylor?
So I went ahead and cleared list 1, but how do I put it in list 2?
Yeah.
So on the calculator, yeah, the list names are just right here. So all you have to do is press second and the one that you want. Okay? It's a lot easier than getting like you know how the Y, you had to go to the vars and all that. You don't have to do that for the list names. Okay? All right, so we'll press enter. And again, we see that the mean for brand B was 35 and the standard deviation was 7.1, just like we calculated. There were 6 pieces of data. It gives us the 5-number summary. Again, notice that the mean and the median are the same. So again, I would say the mean and the median are the same. So also in brand B, there's no skewing. Okay, so I can use either one of those as the measure of center. But if I took these 5 numbers and made a box and whisker plot, or I make my histogram and mark those 5 numbers, I'll see that the data in brand A is a lot more spread out and kind of sporadic than the data in brand B that's a lot more together and kind of consistent. And those are the observations I would want to make. So I come up with a question. Okay, like for your project, this is how it's going to be. I come up with a question. Which paint lasts more months in their outdoor category, brand A or brand B? I go take surveys or whatever to collect data, or maybe you do an experiment or whatever it is you have to collect your data, right? In this case, there's only 6 pieces of data. For your data, that's not going to be the case, all right? So it's going to be a pain in the butt, just like how we had 60 pieces of data in our chart. That's why we got used to using that much data, so we could use it on this. But the thing is, you don't have to order it and do the calculations by hand. The calculator will do those for you. Jenny? Yeah, I'll put it in the project exactly how much I want you guys to get, all right? So I collect my data. I then go and I run the numbers on my data. What are the measures of center? What are the spread? What do the graphs look like? And so the first thing I come up with in my data analysis is like the hard numbers, like no conclusion or me kind of like putting in my input, just like the hard numbers. Like here's the numbers, here's what the visuals look like, okay? Like all the numbers, and then you would make histograms or box plots or dot plots or whatever you want to do with it. Then after that, I start drawing. I do my analysis part of the data, and I say, okay, you can see for both of the brands, the measure of center is the same for the mean and the median, right? So I'd comment on how the data is not skewed. It tends to be centered. But then I would use my visuals and like my 5-number summary, the range, the standard deviation, and the visuals of the graph to show you why I think brand B is more consistent than brand A. And then in the conclusion part of my project, I would say, based on the data, okay, and I would point out maybe a couple of things. Remember, this was the standard deviation, and this is this. I would conclude that if you wanted to have an accurate amount of about 35 months of your paint lasting, you should buy from brand B because they're more consistent in their production of the paint. In brand A, there's a chance that you might get something that lasts a lot longer, but they're super inconsistent in how they produce their paint, and it's kind of just like a big gamble as far as what you're going to get. Okay, so do you guys see how I drew those conclusions? So I collected the data. I looked at the data multiple ways. Visuals, numbers, summary numbers, right? All these kinds of things. The center, the spread. I put all those things in perspective, and then I kind of, in a paragraph, wrapped up what my actual findings would be given my survey or my project, okay? You're either going to compare 2 things in your project, like brand A and brand B here, or you're going to try and find if 2 things are correlated, like we did like height and shoe size, or number of countries visited and language spoken. So you're either going to be in kind of the scatter plot, linear regression, correlation coefficient world, or you're going to be in the world of one variable statistics with means and medians, but you're going to compare 2 sets of them. Does that make sense to everybody? Okay. Then at the end of your survey, after you've stated your results, you should state if you think your results are accurate or not. And what are some things that could make survey results better maybe than another survey? Like if someone tells you, oh, I took a survey and I found out on this campus, like Krispy Kreme donuts are people's favorites. Do you just trust them? What are some things you would want to know about how they collected their data, if their data was biased in any way? What are the types of things that you would look at? Like, is my study a good study about the paints? My conclusions seem to match the number, but what could be a flaw with mine? It actually said in the beginning problem what the possible flaw was. You need more data. Because of the way like the paint is chemical and all this kind of stuff, they only did 6 samples. 6 samples is really not that much. So some kind of hindrance in my project here could be, you know what, brand A looks crappy, like it's really inconsistent, but maybe that's because I didn't collect enough samples, and if I did, maybe it would have looked more consistent. Maybe I just got lucky and the 6 samples from brand B turned out a little better than the 6 samples from brand A. Okay? I don't know, because I only took 6 samples. Okay? Some other things you have to take into consideration is the population, okay, or maybe where they tested this paint or something like that might matter to somebody who's painting their house. California weather is different than Arizona weather is different than the weather in like Alaska or something, okay? So we would have to pay attention to those things. Maybe if you only ask your questions to teenagers and you're trying to represent like the Americans as a whole, maybe that's not fair, right? In my Algebra 2 trig class, some of them wanted to do like, do you deserve democracy? That was literally the title of their survey. One, I would advise against that because it would make people like not want to take your survey, I think, but you know. And so they were testing if they felt that people actually deserved democracy, and how they were measuring that is people's ability to answer questions about how the government works, like about the process of like ratifying stuff and amendments, how bills become a law and all this kind of stuff, So their questions were pretty intense. So what they found is they only wanted to ask adults because they wanted to limit it to voters, right? So they wanted to ask people that were 18 or above. And then what they found was probably the students in their class would have done better on the questions than the people they were polling, because an average 40-year-old person, unless their job entails some of that process, wouldn't know. And then if you're below average in that area like me, you totally wouldn't know. Okay? So I shouldn't be recording this part of it.